Okay, today we'll start in the first lesson in Unit 2, Fundamental Forces in Nature. Okay, when I put the book on the table, it will remain static as it because no force acting on it. But if I affect on this book by a force, the book will change its state from static to motion. Okay, but when I'm affected on the wall by a force to change its position, the wall will in a static state, but it doesn't move. If I affect on the wall by a force, okay, this wall doesn't move from its position. So no change for this state because the force is improper. What is meant by the force is improper? The force equal 0. So the wall remains in a static state as it. Okay? When the ball changes its direction, when the player delivers it with his head, because the direction of the acting force in the opposite direction of the movement object, it changes its direction because the force acting on it in the opposite direction. So the conditions of the force: number one, the force must be proper to change the state of the object. Number two, it changes the direction of the object, so the force must be in opposite direction. So the definition of the force is an attempt that try to change the state of the object from static to motion, from static state to motion state, or vice versa, and it changes the direction. It's an effect that attempts to change the object state from static to motion or vice versa, or attempts to change its direction. The measuring unit of force is Newton. Okay, the measuring unit of force is Newton. The fundamental forces in nature, there are many different types of forces. These forces can't be seen in nature, but we can feel them in some phenomena. There are many forces. I can see it, but I can feel the effect of it, such as lightning, thunder, wind motion, gravitational force, attraction of the object to the magnet. All of these forces, I can see them, but I can feel the effect of it. Okay, middle one. There are forces causing a technological application. There are forces that causing technological application, such as generating electric current, fire, weapons, nuclear explosions, atomic reactors, or nuclear reactors. Okay? Again, the force is the attempts that try to change the state of the object from static to motion, or vice versa, in the opposite direction of the motion. When I say what happens when you affect by a proper force to the object in motion, the object already in motion, and I affect by a proper force on it, but this force in the same direction. If it are in opposite direction, the object change its state from motion to rest. But if in same direction, the object will continue its motion, but increasing the speed. Again, when the object in motion state and the effect on it by a proper force, it continue its motion, okay, and the speed will increases. But if in a static state and the effect on it by a proper force, it will change its state from a static to motion. Fundamental forces in nature that we will study it in this lesson: gravitational force, electromagnetic force, nuclear force. And the nuclear force have two types: weak nuclear force and strong nuclear force. Gravitational force related to the scientist Isaac Newton was the first one who discovered the Earth's gravitational force. When he was standing under a tree and he found an apple falling down to the ground. Isaac Newton standing under the tree, and found an apple falling down to the ground and start to ask himself why this apple falling down, it doesn't going up, moving to right, moving to left, why it falling down. Then he proved that all masses are attracted to the earth. All masses attracted to the earth by a force known as Earth's gravitational force. Any mass attracted to the earth by a force known as Earth's gravitational force. This force depended on the mass of the object. This force depended on the mass of the object. So by increasing the mass of the object, the work done increase. By the meaning of what? If I have a book, table, a chair, and different things, okay, on the ground, the work done that I will do to lift the book from the ground is similar to the work done that I will do to lift the chair from the ground. The work done to lift the book is similar to the work done to lift the chair? No. To lift the chair, you will do more work, more effort. So by increasing the mass of the object, the work done will increases. By increasing the mass of the object, the work done will increases. Why the work done increases? Because when I try to lift this chair from the ground, there is another force trying to take these chairs towards to the ground. When I take the chair towards me, there is another force take the chair towards to the ground. And this force, I can see it, but I feel the effect of it. It's called Earth's gravitational force. It's called what? Earth's gravitational force, or object weight, or object weight. So object weight is the ability of the Earth to attract the object to its center. It is a force of the Earth's gravitational to the object. The object weight can be calculated by using the following relation. Weight equal mass times gravity acceleration. Weight equal mass times Earth's gravitational acceleration. The measuring unit of the weight is Newton. The measuring unit of the mass is kilogram. The measuring unit of gravity is meter per second power 2. And the Earth's gravitational acceleration is 9.8 or 10 meter per second power 2. Okay? Take care, the mass is the amount of matter of an object. The mass is a fixed value, doesn't change by changing the place of the object. When I say the mass of this object on the Earth is 100 kilogram, so the mass on the moon or any place or in any place, it will be equal 100 kilogram. Because the mass is a fixed value, doesn't change by changing the place of the object. While weight variable, it changes by changing the place of the object, because weight equal mass times gravity. So the weight depends on the gravity. Weight equal mass times gravity. So weight depends on the gravitational force, and the gravity different from one place to another. So the weight will be different from one place to another, but the mass is a fixed value. Weight is always bigger than the mass because weight equal mass times gravity acceleration. Okay, middle one, any question till this part? Any question till this part, middle one? Okay, let's continue. Problem, find the weight of the object of 100 kilogram mass, knowing that the gravity is 9.8. Weight equal mass times gravity. Mass equal 100, gravity equal 9.8. So 100 times 9.8 equal 980 Newton. Calculate the mass of the object if its weight 280 Newton. Knowing that the Earth's gravity acceleration 10. To calculate the mass equal weight divided gravity. So weight 280, gravity 10. So 280 divided 10, 28 kilogram. A big box has a number of small balls that are similar in mass If you know that the mass of one pole 0.5 kilogram and the weight of poles 500 Newton, calculate the number of small poles. Here, he needs from me to calculate the number of poles in a box. To calculate the number of poles, we will take the weight of all poles divided the weight of one pole. Weight of all poles divided the weight of one pole. The weight of all poles here equal 500 Newton, but the weight of one pole, no. But I can calculate the weight of one pole from the mass of one pole. Weight equal mass times gravity. Mass equals 0.5 times gravity equal 10. 0.5 times 10 equal 50 Newton. 50 Newton is the weight of one pole. To calculate the number of poles, the weight of all poles 500 Newton divided the weight of one pole 50 Newton equal 100 pole. Okay? In this lesson, you should know that the effective point of an object weight is located at its center. The effective point at its center. So the effective point of the gravity is the center of the gravity. So it said that the Earth attracts the object towards its center. Object's mass is a fixed value, as we said, but the weight is variable. When you approach or move away from the center of the Earth's gravitational acceleration, what happens for it? When you move away from the Earth, going away, the Earth's gravity acceleration decreases. When you move towards the center of the Earth's gravity acceleration increases. Okay? When you transfer from one place to another on the Earth's surface, the gravity and the weight and all things changed. Why? Due to the difference of the distance between the Earth's surface and the center from one place to another, because the Earth have a non-spherical shape. The Earth has a non-spherical shape. So the distance between the center of the Earth and the object on the North Pole is different from the center of the Earth and the object to the equator. The distance between the center and the equator is more than the distance between center and the North or South Pole. And when the distance increases, the gravity decreases. So the gravity on any object on the equator is less than the gravity of the object at the two poles. Okay? So the distance between the center of the Earth and any point of the Earth's surface is less than the distance between the center of the center and any point on the equator. The gravitational acceleration at the two poles is more than the equator. Gravity at the North Pole and South Pole is more than the gravity at the equator. In this problem, if the mass of an object at the equator equal 50 kilogram, what is the mass at the two poles? Well, equal 50 kilogram, because the mass is a fixed value, doesn't change by changing the place of the object. Okay? In this figure, he asks me about the weight of the object whose mass equal 20 kilogram and the gravity, the object at the North Pole, and give me the gravity at the North Pole, and calculate the weight of the object at the equator and give me the gravity of the equator. Mass at the north, mass at the equator, at the south, in any point, it will be equal. So the mass will be equal 20 kilogram. To calculate the weight of the object at north, mass times the gravity at north. To calculate the mass of the object at equator, mass times the gravity at equator. Okay? And the gravity in point A and C will be more than in P, because north and south have more gravity than the equator, as we said before. The second type of the forces in this lesson is electromagnetic force. We studied it before in Junior 5. There are magnetic forces, magnetism produced by the effect of the passing electric current flow the electric charges through a coil. When we bring, look at the opposite figure with me. When we bring an iron bar, soft iron bar, and coiling around it a copper wire, and this wire connected to the battery. The battery is the source of electricity, give the electric current to the wire, and the wire give this electricity to the iron bar. Here, the electric energy will change it into magnetic energy in the iron bar. From what we can know, when we approach an iron filling, something attracted to the magnet towards the iron bar attracts iron filling. The iron bar attracts what? Iron filling. Why? Because the electric energy from the battery is changed into magnetic energy in iron bar, and the iron bar attracts the iron filling towards it. Okay, but when I cut the electric current from the battery, the iron bar left all iron filling, because when we cut the electric current, there is no electric energy to change into magnetic energy, so the iron bar doesn't work as a magnet. The iron bar attracts the iron filling, okay, because the electric current changed it into magnetic effect. This is the idea of making electromagnet. This is the idea of making electromagnet. Electromagnet, it's made up of insulated copper wire coiling around a bar of wrought iron to be easy to gain or lose magnetism, okay, and connected to the battery. The idea of how it works, it converts the, here it converts the mechanical, no, here electromagnet, correct it. It converts the electric energy into magnetic energy. It converts the electric energy into magnetic energy. When the electric current passes through the coil, it works as a magnet. It's used in making many devices such as electric winch, crane مكتوبة هنا غلط. Correct it, crane. C-R-A-N-E. Electric bell. The idea of making electric winch or crane is the changing of the electric energy into magnetic. How? The driver push on the electricity in the electric button, okay, and connect the electricity. This electricity flow through the wires until it reaches the iron bar. This iron bar work as a magnet to lift anything. And when the driver wanted to put this thing, it cut the electric current by turning off the button, so it doesn't work as a magnet, so it falls down this thing from it. So the idea, the making the electromagnet is used in making electric winch or crane and electric bell. Okay, middle one, understand? Okay. We have another application which is called electric generator or dynamo. Dynamo, it converts the kinetic energy, mechanical energy into electric energy. Dynamo converts the kinetic energy into electric energy. Kinetic energy, when we move a copper wire around the magnet, this kinetic energy changed into electric energy. The dynamo, the example of dynamo, the dynamo in a bike. There is a dynamo electric generator on the wheels of the bike. When it starts to move, there is a kinetic energy changed into electric to light the lamps of the bike and make the sound of the electric bell in the bike. Electric motor is the third application. Electric motor is the opposite to the dynamo. Electric motor opposite to dynamo. It converts electric energy into mechanical. In dynamo, the kinetic or mechanical changed into electric. But electric motor, the electric will change it into mechanical. Again, electric generator, mechanical to electric. Electric motor, electric to mechanical. Like the motor in a fan. When it connected the fan to electricity, there is electric energy. The fan will start to move, there is a kinetic energy. Like the motor in a blender or a mixer. Okay. The third type of energies, of forces, of the fundamental forces in nature is the nuclear force. Nuclear force, scientists have discovered that the atom stores a massive amount of energy inside its nucleus. The scientists discovered that the atom stores a massive amount of energy inside its nucleus. This massive energy is accompanied by forces known as a nuclear force. Inside the atom, there is a nucleus. This nucleus generates a nuclear force. Okay, the nuclear force can be divided into two types: weak nuclear force and strong nuclear force. The weak nuclear force used to get radioactive element, weak nuclear force of radioactive element. This element gives me radiation. Radioactive elements and radiation which are used in medicine, scientific researches, and industry. So the weak nuclear force is used in medicine, scientific researches, and industry. But the strong nuclear force, these nuclear forces generate a large amount of nuclear energy. Strong generate a large amount of nuclear, these nuclear force generate a large amount of nuclear energy. This nuclear energy can be used in producing of electricity, producing of electric energy, and in military purposes, okay? So the strong nuclear force generate a large amount of nuclear energy that used in producing electricity and military purposes. And these strong nuclear forces that generate a large amount of nuclear energy used in producing of electricity, Egypt is seeking for using this nuclear energy to produce electricity beside the other ways of producing electricity. Okay, middle one, we finished this lesson. Thank you for listening. You have a homework page, homework sheet. Page what? Page 36. Page 36. Okay, you have a homework, page 36. If you have any question on this lesson, you can send me on WhatsApp. Okay, middle one. Any questions? Thank you. Goodbye.